In April 2025, the James Webb Space Telescope detected something impossible 120 light-years away. A chemical signature known as dimethyl sulfide, drifting in the atmosphere of an alien ocean world. On Earth, this gas is produced by only one thing: living, breathing biological organisms. We thought we finally found them, but the universe was hiding a terrifying deception: the gravity matrix. Today, we investigate the phantom biosignature of JWST and the chilling reality of the Great Silence. For generations, humanity has stared into the dark abyss of space, desperate for a whisper in the void. In the 1970s, we launched the Voyager probes, carrying golden records as a greeting to the cosmos. We built massive radio dishes, sweeping the galaxy for a stray broadcast, a mathematical greeting. But the cosmos responded with nothing but deafening, terrifying silence. This is the Fermi Paradox. If the universe is so vast and so old, where is everybody? By the 2020s, astronomers realized that listening for radio waves might be a profound mistake. If alien life is primitive, like the algae and bacteria that ruled Earth for billions of years, it won't build radio towers. But it will breathe, it will eat, it will fundamentally change the chemistry of its sky. To find them, we didn't need a radio. We needed a chemical nose. We needed the James Webb Space Telescope. Orbiting 1,000,000 miles from Earth, JWST's golden honeycomb mirrors are designed to catch ancient starlight. When a distant planet passes in front of its host star, a microscopic fraction of that starlight filters through the planet's atmosphere. Different molecules absorb different colors of light, leaving behind a unique barcode, a transmission spectrum. In late 2023, Webb pointed its sensors toward the constellation Leo, locking onto a sub-Neptune exoplanet named JWST. It is a world unlike anything in our solar system, a Hycean planet 8 times the mass of Earth. Theoretical models suggested JWST might be entirely engulfed by a global, boiling ocean of liquid water, crushed beneath a thick, suffocating envelope of primordial hydrogen gas. When the first data arrived, it was a watershed moment for astrophysics. Webb's instruments definitively detected methane and carbon dioxide in the alien air. But hidden deep in the noise of the spectrum was a faint, almost imperceptible fluctuation. A chemical fingerprint pointing to a highly complex molecule called dimethyl sulfide, or DMS. On Earth, DMS is responsible for the distinct, briny smell of the sea. It is produced almost exclusively by marine phytoplankton, microscopic life forms drifting in our oceans. In April 2025, a team at the University of Cambridge published an explosive paper. Using Webb's mid-infrared instrument, they claimed to have found the strongest hint yet of biological activity beyond our solar system. The announcement sent shockwaves through the global astrophysics community. If this fragile, sulfur-based molecule was truly drifting in the winds of JWST, it changed our place in the universe. It meant that biology was not a miraculous anomaly confined to a single pale blue dot. It meant the cosmos was a sprawling biological engine, teeming with invisible organisms. But to understand the magnitude of this claim, we must look at how dimethyl sulfide is actually forged. On Earth, DMS is an incredibly complex, energy-heavy molecule to assemble. It requires a highly specific biological mechanism, an enzyme produced only by living marine algae. Without life to actively build it, this gas quickly degrades, obliterated by ultraviolet light from the host star. So, if we are seeing it 120 light-years away, something must be continuously replenishing it. An ocean-wide bloom of alien phytoplankton, churning out biological gas under a dark red sky. But astrophysics is a brutal, unforgiving crucible. Extraordinary claims demand flawless evidence. The original 2023 observation used Webb's near-infrared imager, which only caught a fleeting, overlapping signature. The dimethyl sulfide spike was perilously close to the spectral signature of methane, a highly common, lifeless gas. It was like trying to hear a single, fragile whisper in the middle of a roaring cosmic hurricane. To confirm the biosignature, researchers pushed the James Webb Telescope to its absolute operational limits. They modeled the violent photochemistry of JWST, simulating the harsh radiation of its host star. Red dwarfs are notorious for aggressive solar flares, blasting their planets with sterilizing ultraviolet radiation. Could this intense stellar radiation interact with a hydrogen-rich atmosphere to create a false positive? Could a purely lifeless, geological process mimic the exact breath of a biological organism? The scientific community fractured into deep skepticism. The stakes were no longer just astronomical. If the signal was real, we had found our cosmic neighbors. If it was false, the void was darker than we thought. Astronomers soon realized that early models of Hycean planets might contain a fatal, hidden flaw. The crushing gravity at the bottom of a global ocean might compress water into a layer of high-density ice. Known as ice VII, this bizarre, ultra-compressed water acts like impenetrable solid rock. This ice barrier would choke off the ocean from the planetary core, starving it of the minerals necessary to spark life. Without a rocky seafloor to provide nutrients, a beautiful ocean world becomes a sterile, global desert. A massive sphere of liquid water, utterly devoid of a single living cell. To settle the debate once and for all, NASA authorized a desperate, high-stakes follow-up observation. Webb's mid-infrared instrument was commanded to stare directly at JWST for an unprecedented 8-hour exposure. They needed to separate the phantom whisper from the noise, but what the new data revealed would shatter everything. The James Webb Space Telescope's mid-infrared instrument, or MIRI, operates at much longer wavelengths than previous observations. It possesses the power to pierce through the confusing overlap of molecular signatures, seeing the true chemical skeleton of the planet. For months, researchers meticulously processed the new MIRI transmission spectra, hunting for the elusive biological gas. They carefully stripped away the dominant, blinding signals of methane and carbon dioxide. The world held its breath. Was this the moment humanity finally found its cosmic twin? But as the high-resolution data finally rendered, a chilling reality began to emerge from the noise. The faint, tantalizing spike of dimethyl sulfide, the holy grail of astrobiology, started to shift and break apart. It wasn't a distinct chemical barcode at all. It was a terrifying optical illusion. At lower resolutions, two overlapping bands of regular, lifeless methane perfectly mimicked the signature of DMS. It was a cosmic mirage, a cruel trick of light played across 120 light-years of empty space. When MIRI looked closer, the fragile spike of life flattened out into a dead, lifeless line. The biological signal completely vanished. The ocean world of JWST was utterly, profoundly dead. The realization hit the astrophysics community, with the devastating force of a supernova. The phantom biosignature wasn't a failure of the telescope. It was a testament to the brutal difficulty of interstellar chemistry. We are searching for a microscopic whisper through a lens that distorts reality itself. The sudden death of the JWST signal brings us face to face with the terrifying depths of the Great Silence. If the most promising ocean world in our galactic neighborhood is completely sterile, how rare is biology? Some physicists now argue that Hycean planets, once thought to be havens for life, might be universally uninhabitable. Their massive, hydrogen-rich atmospheres might inevitably trigger a runaway greenhouse effect, boiling their global oceans into a hellish, supercritical fluid that destroys all organic compounds. A planetary pressure cooker, crushed by atmospheric weight millions of times greater than Earth's. A realm where not even the simplest, hardiest extremophile bacteria could survive for a fraction of a second. As we cross off one candidate after another, the Fermi Paradox casts a longer, darker shadow over humanity. Perhaps the chemical spark that ignited life on Earth was a statistical anomaly so impossibly rare. It only happened once. A freak, isolated quantum accident, never to be repeated in the 13.8 billion-year history of the cosmos. As the glowing hope of JWST faded into the black, astronomers turned their gaze back to the unrelenting void. Webb's golden mirrors shifted slightly in the deep cold, hunting for the next target in the endless dark. The silence of the universe is not just the absence of sound. It is the terrifying absence of a chemical heartbeat. Every time we think we hear a whisper, the cosmos reminds us of its immense, unfeeling scale. Yet even as the illusion shatters, we cannot stop listening to the dark. If the universe is truly a sterile, silent void, then the implications for humanity are staggering. It means the Earth is not just another rocky planet in a crowded cosmic neighborhood. It is a miraculous biological oasis, an impossible sanctuary hanging by a gravitational thread. This terrifying realization forms the core of the rare Earth hypothesis. The theory suggests that while microbial life might spark briefly in the dark, complex biology requires an impossibly perfect sequence of events. We survived because Jupiter acts as a massive gravitational shield, sweeping up planet-killing comets. We thrived because a rogue planetary collision created our unusually large moon, stabilizing our axial tilt. Without these exact, random cosmic accidents, Earth would be just another dead rock in a silent galaxy. We are the universe experiencing itself, the only known consciousness capable of looking back at the stars and asking why. And with that unique status comes a terrifying, almost unbearable responsibility. As Arthur C. Clarke famously wrote, two possibilities exist. Either we are alone in the universe or we are not. And both are equally terrifying. The cruel illusion of JWST was a harsh lesson for astrophysics. It taught us the ultimate danger of projecting our own terrestrial biology onto the alien dark. Life out there, if it exists, might not breathe oxygen or excrete dimethyl sulfide. It might be fundamentally incomprehensible to our chemical models. The James Webb Telescope continues its relentless hunt. Its golden eye is scanning the atmospheres of the TRAPPIST-1 system as we speak. But as we close the chapter on the phantom biology of ocean worlds, we are forced to ask a much darker question. What if the silence of the cosmos isn't an absence of life at all? What if it's an active, deliberate hiding? What if the reason we don't hear any radio signals, or see any glowing alien atmospheres. It is because any civilization loud enough to be heard gets hunted down and eradicated. In late 2025, just as the JWST debate was finally put to rest, a new alert flashed across the screens at Mission Control. Webb wasn't looking at a tiny exoplanet's atmosphere. It was staring directly at a mature, stable main-sequence star. And something gargantuan was blocking its light. Not a planet, not a cloud of dust, but a rigid, mathematically perfect structure. A shadow with straight, engineered edges, larger than the orbit of Jupiter. If JWST was the phantom biology of the universe, this new anomaly represented something far more terrifying. Engineering, a cosmic megastructure built by a civilization that survived the Great Silence. The universe is not empty. We have simply been looking for microbes, while ignoring the gods hiding in the dark forest. And in part 2, we turn our sensors toward them.